Okay, this is the final lesson of the week, lesson 78, the hyperbola. We've already graphed parabolas, ellipses, and circles, so this is just one more thing to graph. The equation for hyperbola is similar to the equation for an ellipse. It's x squared a squared. Instead of being plus, it's minus y squared over b squared equals 1. Now there's two different forms of the equation. The standard form with the center at the origin and the foci on the x-axis has the x part first. The way you can think of it is the x-axis is symmetric around the x-axis. The point right here and right here is on the x-axis. That would be your foci. The focus is foci, I guess you'd say. The other form is with the foci on the y-axis. And that one would be the y squared would come first, and then the x squared. So we're going to graph these things. They're very easy to graph. Let's look at an example of one. You can tell it's a hyperbola because of the negative sign. The ellipse would be a positive sign. It has to be set equal to 1. It has to be in standard form in order to graph it. So the first thing you're going to do is you're going to set x equal to 0. So it would just wipe out this term. And we would figure out, oops, we wouldn't set it, yeah, we could set x equal to 0 first. You can do it either way first, but I'm going to just set x equal to 0. And if we do that, we're going to get negative y squared over 4 equals 1. We would get negative y squared equals 4. Y squared equals negative 4. Y is going to equal plus or minus 2i. And that's a problem because this is not a complex number plane. It's a regular rectangular coordinate. So just keep that in mind. Let's set y equal to 0 now. If we set y equal to 0, this term is wiped out. So we get x squared over 9 equals 1. We would get x squared equals 3, and x equals plus or minus 3. Square root of 3. Now we would just, I meant to say 9 over here. So we get x equals plus or minus 3. The way you graph these is we're going to treat, this is going to be our x-axis. I'll do these in red. And this is going to be our y-axis. We're going to put these points on. So x is going to be at 3, negative 3. And we know that our hyperbola is going to be symmetric around the x-axis because the x comes first. The points that we put on the y-axis are not really real points because they're imaginary, so they're not going to be our foci. I'm going to put those points on just so that we can get an accurate hyperbola. So you put a point on 2 and negative 2. And then we're going to construct a rectangle around these points. Like that. And you come up with faster ways to graph these. Oops, I think I lost my rectangle. Then, after you get those points on, then we're going to make some lines crossing through the rectangle's vertices. I'm going to put a line through here. These are going to be our asymptotes. It's probably a lot better I did this lesson on the computer anyway, the way my drawings are. And they form the structure to do our hyperbola. So then we just take, and these are our asymptotes that we formed. So our hyperbola are going to approach these lines but never touch them. So I'm going to try to draw it in here. So it's going to look like this. Woo! Let me try that again. This would be our hyperbola right here, the blue. Not very is actually our graph. So our hyperbola. So this is the hyperbola with the foci on the x-axis. You just have to figure out the y so that you can come up with your little rectangle to make your asymptotes to graph your hyperbola. So the hyperbola is actually just the blue lines. The rest is just your setup. Let's try another one. Okay, you can see on this one that our foci, because the one that's not going to be imaginary right here is going to be the points on your y-axis. So I'm going to set x equal to 0, and we're going to get y equals y squared equals 4, y equals plus or minus 2, and if we put y equals 0, we're going to get x squared equals negative 25, x equals plus or minus 5i. So we put those points on there. This should have said, okay, 2. So we're on the y-axis, we're going to put our points on 2, negative 2. On our x-axis, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. And we create our rectangle. Then we draw in our asymptotes through the vertices of our rectangle. These are quite easy to do. And then finally we draw in our hyperbola. Oops. This time our points are going to be on the y-axis, because our points on the x-axis are really just imaginary. Strange but true. And so you can see this one's going to be a little bit wider of a hyperbola. And here we go. I'm going to do this one. And that is how you graph a hyperbola. Now we're going to get them when they're not in standard form like this one. So the first thing you have to do is get it into standard form. So we're going to, as soon as I change my color here, we're going to get 4y squared minus 9x squared equals 36. We have to get a 1 right here, so we divide everything by 36. So we get y squared over 9 minus x squared over 4. How do you like how everything is a perfect square and everything works out perfectly with the numbers here? Equals 1. You can see our points are going to be on 3. We can start skipping a few steps. And negative 3. And 2 and 2. And we'll have little points here where our lines will go through. If I make a rectangle, make our lines go, our asymptotes go through these points best as we can. And do another one this direction. I like how when I miss the points I can readjust them. There you go. Now you want it to be on the y-axis, because the ones on the x-axis, it's negative, they're going to be imaginary. So we just draw in our, oops, did that again. And we just draw in our hyperbola. The asymptotes determine how wide how wide each of the parts of the hyperbola are. So that is it for lesson 78.